This technical safety analysis of industrial hoisting and rigging dynamics highlights the critical nature of dynamic loading. When a load oscillates abruptly, force multiplication can surge to twice the actual weight, potentially exceeding the safe working load SUL and causing mechanical failure. Rotational inertia in large objects quickly becomes uncontrollable by human strength alone. A primary procedural error in this incident was the absence of taglines, which are essential for maintaining directional control from a safe distance and preventing hazardous side loading on the crane boom. Furthermore, personnel failed to respect the fall cone, positioning themselves within a strike radius that accounts for oblique trajectories during a fall. Adherence to the 4-inch rule for trial lifts and proper sling angle calibration is mandatory to ensure stability. Finally, maintaining a single signal person is vital to prevent communication breakdowns during critical maneuvers. This technical analysis examines critical mechanical failures and operational risks in industrial settings, emphasizing the necessity of stringent safety compliance. High heat operations on sealed vessels can trigger rapid thermal expansion and pressure explosions if residual gases are not purged, turning components into projectiles. When hoisting loose materials, the absence of lifting cages often leads to load retention failure due to dynamic loading forces that snap substandard rigging. Furthermore, heavy vehicle maintenance poses risks of unintended drift and hydraulic collapse, creating lethal pinch points for unprotected personnel. To mitigate these hazards, strict adherence to lockout takeout LOTO protocols, the use of mechanical safety struts and the enforcement of exclusion zones are vital. Ultimately, prioritizing person over property and utilizing spotters for a 360-degree perspective remain the final defenses against high-risk industrial accidents. This technical analysis examines the critical safety violations seen in the footage, emphasizing the necessity of standard road work protocols. The incident primarily stemmed from a failure to account for heavy vehicle blind spots. The workers' crouched position placed them well below the driver's line of sight, while the lack of traffic control devices like cones or buffer space meant the motorist had no cue to slow down. The individual survived by landing in a narrow survival zone between the axles, highlighting the dangers of cognitive tunneling where task fixation destroys situational awareness. Furthermore, the absence of a dedicated spotter and shadow vehicles created a systemic failure in risk management. To ensure safety, crews must utilize high-visibility gear and physical barriers. Professional protocols, not luck, are the only way to eliminate workplace risk. The warehouse collapse incident underscores the critical importance of structural stability and operational discipline in material handling. The primary failure was the use of column stacking without interlocking patterns, leaving the tall pillars hypersensitive to any shift in the center of gravity. By removing a bottom-tier sack, the worker inadvertently eliminated the structural anchor, triggering a vertical free fall of tons of material. This hazard was exacerbated by the line-of-fire positioning of personnel and narrow aisles that functioned as a space trap, preventing any quick evasion. To mitigate these risks, facilities must implement top-down retrieval protocols and invest in industrial racking systems that isolate tier loads. Prioritizing safety over convenience, establishing buffer zones, and conducting daily stability inspections are essential to preventing such catastrophic outcomes and ensuring a secure workspace. This technical breakdown examines the critical safety failures involved in a worker's narrow escape from a high-altitude fall. The incident was driven by mechanical instability, where inertial forces and engine vibrations on a smooth, curved tank surface compromised the worker's balance. A primary violation was the total absence of fall protection systems, such as OSHA-mandated anchorage points or personal fall arrest harnesses. Psychologically, overconfidence and complacency led the worker to rely on personal balance rather than engineered controls. Furthermore, a breakdown in communication between the operator and the worker, combined with the lack of emergency stop protocols, left the individual to self-rescue from a precarious hang. To mitigate such risks, facilities must enforce a no-contact rule for moving loads and utilize proper aerial work platforms instead of direct tank access. Strict adherence to safety regulations is the only way to prevent irreversible industrial outcomes. This technical analysis examines the high-risk release of stored energy during mechanical maintenance, where pressure dynamics in sealed chambers can turn fasteners into high-velocity projectiles. The incident underscores the danger of bypassing lockout-tagout LOTO protocols. Failing to achieve a zero-energy state allows trapped pressure to trigger explosive discharges. By striking components under load, workers exacerbated the risk, placing themselves directly in the line of fire. Unlike visible hazards, internal pressure is a silent threat, often leading to a dangerous efficiency fallacy where safety steps are skipped to save time. To mitigate these risks, crews must follow strict bleeding procedures, utilize containment barriers like safety cages, and ensure only certified technicians handle high-pressure systems. Ultimately, the golden rule remains: never turn a bolt until internal pressure is verified at zero. This technical analysis evaluates the biomechanical risks and safety violations in manual material handling, specifically focusing on excessive weight-bearing hazards. By stacking 5 heavy bags on one shoulder, the center of gravity shifts significantly off-center, making stability nearly impossible to maintain during a descent. This creates massive compressive stress on the lumbar spine and high-impact forces during a fall. Psychological factors like showboating and the efficiency fallacy often lead workers to ignore safety warnings for high-risk feats. Furthermore, descending without three-point contact while the line of sight is obscured makes a misstep inevitable. Proper ergonomics require breaking down loads and using mechanical aids. Ultimately, brute force is no substitute for technique. Safety and consistency are far more valuable than a momentary display of strength. This agricultural incident highlights the severe risks of improper gear engagement and high torque output in heavy machinery. By starting the engine while the transmission was in gear, the operator caused the tractor to lurch forward autonomously. The machine's immense power at low speeds creates kinetic energy that easily overcomes physical resistance. Key hazards included high RPM rotary tillers and critical pinch points between the wheels and frame. A major safety violation occurred through ground starting instead of using the operator's seat, placing the worker in the line of fire. To prevent such outcomes, strict adherence to the neutral gear rule, establishing safety perimeters, and maintaining emergency shutoffs are mandatory. Absolute compliance with technical safety procedures is the only safeguard against the unforgiving nature of industrial and farm equipment. This technical analysis evaluates the physics and safety violations in a tanker slip and fall incident, highlighting the urgent need for fall protection. The convex surface of industrial tankers creates a steep slope that reduces foot traction while gravitational forces increase exponentially. On slick metal, static friction quickly becomes kinetic friction, making self-recovery nearly impossible. Fall from 10 feet occurs in just 0.78 seconds, leaving no time for defensive reflexes and resulting in impact forces up to 10 times the body weight. The absence of fall restraint or arrest systems is a critical failure. Standard procedures mandate the use of dedicated platforms and guardrails rather than direct climbing. Facilities must invest in overhead gangways and empower workers with stop work authority to prevent these life-altering consequences. Remember, gravity never takes a day off. The industrial incident involving rotating shafts highlights the severe dangers of in-running nip points and mechanical entanglement. These nip points create immense frictional force that pulls objects in at operational speeds, far exceeding human strength and reacting faster than a worker's withdrawal reflex. A critical factor in such accidents is often improper attire. Loose clothing or gloves can snag on textured surfaces, acting as a tow rope that drags the individual into the machinery. The lack of engineering controls, such as physical guarding, light curtains, or accessible emergency stops, leaves workers vulnerable. To prevent these outcomes, strict adherence to lockout-tagout LOTO protocols and the use of snug-fitting P are mandatory. Ultimately, combining robust mechanical safeguards with disciplined safety awareness is the only effective defense against the unforgiving nature of rotating industrial equipment.